Hi everyone, I am Gauri PS, lecturer, Department of Radiology, Global College of Allied Sciences. Today we are going to discuss about the topic radioactivity in radiation physics. First is about introduction. Radioactivity is a nuclear phenomenon, that is, it is a spontaneous disintegration of unstable atomic nuclei with an emission of heavy types of radiation. First, it was discovered by Henry Becquerel in the year 1896, where Marie and Marie Curie explained the research of radioactivity. First, it was first discovered by Becquerel, that is, he left some of the uranium salts wrapped in a black paper on a photographic plate in a dark room. And when he developed this photographic plate, he found that the plate was affected. Hence, he repeated this experiment with other salts of uranium, and from that, he concluded that the uranium and its salts emit some of the invisible radiation that can be passed through the paper, wood, glass, etc., and it also affects the photographic plates. So, these radiations he concluded to have that they are alpha, beta particles, and also about gamma radiation. Then, what is an atom? Atom consists of protons, neutrons, and electrons. Protons are the positively charged particle, and electrons are the negatively charged particle, whereas the neutrons has no charge. And these protons and neutrons will be present within the nucleus of an atom, whereas the electrons will be revolving around the atom on the specified energy levels or shells. And if an electron or a proton or a neutron has been removed from an atom, the atom will be losing its stability, and this nuclear instability will be causing the radioactivity. Usually there is a two types of radiation, that is radioactivity, that is about natural radioactivity and artificial radioactivity. The natural radioactivity, it is a phenomenon of spontaneous emission of, it is a phenomenon of spontaneous emission of rays such as alpha, beta and gamma by heavy elements which are having an atomic number that is greater than 82. So it is called as natural radioactivity. For example, we can say it as radium 226. Next is about artificial radioactivity. Artificial radioactivity, we can say it also as an induced radioactivity. It was discovered by Curie and Joliet in the year of 1934. That is, they were studying the disintegration of light elements by alpha particles. So suddenly they found that when the light elements such as boron, aluminum were bombarded with alpha particles, an unstable nucleus was formed, and this nucleus has disintegrated spontaneously. And the artificial radioactive substance will be emitting the electrons, neutrons, positrons, or gamma rays. And they also follow the same laws of decay as natural radioactivity, for example, cobalt 60 and phosphorus 32. So the term activity will be referring to the disintegration rate of radioisotope, and is measured by the unit Curie, and 1 Curie is the number of disintegration per second from 1 gram of radium. It is found to be that 3.7 into 10 to the power 10 disintegration per second. Next is about alpha radiation. Alpha radiation means they are helium nuclei with high ionization and has a low penetrating power in comparing with the beta radiation and gamma radiation. Next is about beta radiation. Beta radiations are the fast electrons or positrons, and thus has a moderate penetrating level in comparison with the alpha radiation and gamma radiation. Next is about gamma radiation. Gamma radiations are the electromagnetic radiation that has a high penetrating power, and it do not contain any charge within it. Next is about radioactive decay. What is radioactive decay? Radioactive decay is the spontaneous transformation of unstable nuclei into an stable nuclei. Uh, this was followed on based of a radioactive decay law. That is, the Rutherford and Soddy found that the rate at which a particular radioactive material disintegrates was independent of the physical and chemical condition. So their law states that the number of atoms that disintegrate in unit time will be proportional to the number of disintegrations or the number of radioactive atoms which are present at that time. That is, n is equal to n0 e power e power minus lambda t. That is the radioactive disintegration law or the radioactive decay law. Next is about half-life. Half-life is the time which is required for half of the radioactive nuclei to decay. Next is about mean life. Mean life is the average lifetime of a radioactive nucleus. That is, mean life is equal to 1 by lambda. Usually the units of radioactivity are becquerel and curie. Next is interaction of matter. Usually the interaction will be taking place with the ionization and excitation of the atoms. And this radiation which will be passed will be detected by means of Geiger-Müller counter, scintillation detector, and also by means of an ionization chamber. What are the applications of this radioactive materials? That is, they are in the medicine field, they are applied in the diagnostic imaging, nuclear medicine, and radiotherapy. In industrial applications, we use them in the thickness gauging, radiography, and also in leak detection. It has some of the biological effects, that is, somatic and genetic effects of radiation exposure. Due to the radiation effect, the somatic effect will affecting only the surface of the body particles, and that cannot be converted from one generation to next. Whereas in genetic effects, it will be transferred from one generation to next generation, that is about chromosomal aberrations. The next is about the radiation protection. So what are the protection we can make in a radiation? That is about, it is based on the principle of ALARA. That is about as low as reasonably achievable. That is, it should have a shorter timing, longer distance, and a proper shielding. Then from this we can understand that the radioactivity is a fundamental to the radiation physics and also in medical imaging. Thank you.